You talked about glyphs. Let's make it a little bit more complex, because a glyph by itself is not sufficient to accomplish everything. The real question becomes, how do we go from the fact of having a font in a PDF file to knowing which glyphs are to be drawn on the page? How does Acrobat, for example, figure out which glyphs it has to show from all the ones that are available in this font? We know that the font contains that glyph information. We just saw that. We know that the PDF contains the font, but where does it tie together? And I'm going to show you something else that you could think is very, very geeky. It is, but it's not that difficult once you start looking at it. What you're seeing here on the top left is part of a PDF page description. Whether you know it or not, PDF on a page, the way the file format works, it actually describes the things that are going to be drawn on the page in a text-like language. And that is a fragment of that language that you see. On the right bottom, what you see is the actual content of the PDF. So how that looks. The text fragment you have on the left translates into "you have been invited" when you show that in Acrobat. And I put the explanation of each line next to it, and you can see that there is a special pair of commands to draw a text object: BT, begin text object, end text object. Then there are some commands that have to do with color. There are some commands that have to do with positioning. Those are the matrix things. The most important bit perhaps here for our purpose is this TF command that is in there, because that sets the current font, the font that is going to be used for drawing. We already know that the font is in a PDF document. That is, it's in there somewhere, and it has a name. And this TF command says, look for the font with the name TT0 and make that the current font. This is exactly the same as you would do in Word by going to one of the toolbars and selecting a particular font to draw, except that, of course, in the PDF, they don't use the actual name. They use some kind of identifier that finds that in the resources dictionary of that page. And then you see two TJ commands, one where you can see the letters U and one where you can see the words "have been invited." And those are commands that draw text on the page. There are two different commands. One allows drawing with kerning, the other one not. And kerning is changing the positioning between the glyphs on the page from what they normally would be. So what you can see there is that the spacing between the letter Y and the O has been adjusted by the PDF engine to make it a little bit more aesthetically pleasing, probably. So this is what happens when you open a PDF file in an application such as Adobe Acrobat. Acrobat will read this textual description of what is on the page, and it will convert that in objects that are shown on the page. In this case, it will convert it to a number of words on the page in a particular font using some yellow or yellowish CMYK color. Now, how does that work exactly? Because what you have in the page description is a Y, and that actually, if you would look at it, is represented by a number. And the number in this particular case is 89. That is not important, but what is important is that in this page description, you just have a bunch of numbers. So how does that number in the page description lead to a particular glyph? Well, that font that is the active font contains a table that maps characters to glyphs. So it maps that number 89 that we see in the page description to glyph number 59 in the font. I looked it up for this particular font and it happens to be that. It's not always the same, it can vary, but in this particular font, there is a mapping that says if you see the number 89, then you have to map it to glyph number 59. And if I then go look in the font, then that glyph comes out as a capital Y. So again, each time you open a PDF file in Acrobat, this is all going on in the background. Each character code, each number that you have in the page description has to be mapped in the active font, and then the glyph that comes out is drawn on the page at the position that those commands will give. That sounds very complex. In reality, it is about 10 times as complex as what I describe. What I've given you is the theoretical way that this works. This is the theoretical system behind it, and we can call this an encoding, but in reality, there are probably 5 different ways that this can work. There are all kinds of different ways to map things from a character code to a glyph. But in essence, all of those things do the same thing. And when people talk about encoding, well, an encoding is a system to map from a particular number that appears somewhere to a glyph that is going to be shown on the page. So, any questions about that?
Yeah, there are questions. It's starting. Some of them are going to be covered later in the presentation, so we will not cover them. But there are some that I think have something to do with this. Probably a combination of this one and the first one that you had, or even the 3 first topics. I have a question from the audience where somebody asked what happens if fonts have the same identifier in a PDF. So probably the first question is it possible to have the same identifier? And if yes, what is the result?
Well, it depends on what you mean by identifier. A font has, so like I said, a font has a name. I'm assuming that you're referring to the TT0 part, the internal name of the font in the file. That should be unique on a page level. So if I have multiple pages in a PDF, they all could have a font that is called font1 or TT0 or TT1, whatever it is. But on a page level, that should be unique. So you can't have a page where you have 2 fonts with the same internal ID, because in that case, the PDF engine wouldn't know which of those to take. But if you open, in general, a PDF file, you can definitely have the same name or ID for that font on different pages. That is not a problem, because each page will refer to the one that belongs in the resources dictionary of that page.
Okay, if you can just go back on the slides where you had the structure and
Of course.
because here, yeah, this one, yes. I have a question. Is the value 92 the distance of the kerning like 92%?
No, it's not 92%. It is a total coincidence that it's a number under 100. We will talk a little bit about fonts and character widths later as well. The number that you see here has to be interpreted in the coordinate system set up by the text matrix. So this TM command that you see there sets a text matrix. The last 2 values in that text matrix, I'm not going to give you very complicated mathematics here, but the last 2 values are basically an X and a Y value. So that explains where that particular font is going to be, or that particular text rather, is going to appear on the page. And you can actually see that. So it's X and Y. X is normally first, and Y would be the second bit. The first numbers that you have, the 720072, will ultimately define the size of the font. And you can see that it is 72 in the first line, the first text matrix command, and it's 30 for the second one, and that's because the second piece of text is a lot smaller than the first one. This 92 has to be understood in that scenario. So it refers to something in the font. It definitely is not a percentage, but it's difficult to explain what it actually is without going into all kinds of technical details. But not a percentage. It's actually going to be a very small fraction of a character in this particular example, probably.
Thanks. Very clear. Still on that page, I have another question. I don't know if we go into technical, but anyway, somebody asked, what is the difference between the TJ with capital J and TJ with lowercase g?
Yeah, I would have to, I'm afraid of saying something that is not correct because I haven't read it in the PDF specification again, but as far as I remember, the TJ capital allows you to specify these kerning values. You can see that it looks a little bit different, while I think that the TJ, the way it is here, just puts text on the page without kerning possibilities. I think that it's the difference. If you want to know for sure, you would have to look it up in the PDF specification. Any version, this has been in there since the very beginning, so it's not a modern thing. It's just yeah, how PDF works. There are probably 2 or 3 other ways of putting text on a page as well that work all a little bit differently depending on the scenario.
Winter is coming, so it's really nice to have that kind of book to read for the long nights, I guess.
I think it's about 1,100 pages now, so good luck with that.
On the next slide, if you can go on the next slide. Yes, on that one, I have a question from the audience asking if those numbers have something to do with Unicode numbers.
Yes and no. Unicode is a particular example of an encoding. In this case, I don't believe that the encoding that we have here is actually Unicode. It is probably something like a Latin encoding, which is a very common one in Europe. I should say Western Europe. But ultimately, they are related. Unicode is an encoding system, so it is something that is used to map from character codes to a particular glyph eventually, and that's the same thing that is happening here. So when we talk about encodings being the mapping between character codes and glyphs, then yes, there are multiple of those, and Unicode is one of them. Actually, Unicode is multiple of them because there are multiple versions of Unicode. You have something that is called UTF-8, then you have UTF-16, 2 different versions of it, and so on. So again, it's more complex than what I'm saying, but Unicode is a possible encoding system that you can use.